Hello, everybody. My name is Connor Bleisch. I'm a first-year graduate student at the University of Alabama in Huntsville. I'm getting my master's degree in computer science, and I'm going to show you an immersive narrative visualization of the KNP complex wildfire that happened in California in 2021. So what is an immersive narrative visualization? It's basically using data to tell a story. So it's very you can walk around in it. You can see how things develop with the data. All these data sets combined together into one simulation. So KMP complex fire happened from September 9th to December 15th of 2021. It started due to a lightning storm that caused three fires called the Colony Fire, the Cabin Fire, and the Paradise Fire. The Cabin Fire was very quickly put out at 1 acre, but eventually the Colony and the Paradise Fires, they combined into the one fire that we now call the KNV Complex Fire. So here you can see a timeline. That's the beginning of the fire, all the way to the most intense moments of the fire in October, and then here's the surveying in November and December, seeing the wreckage. And it was about 88,000 meters, or 88,000, not meters, acres. And yes, so I'm going to show some typical visualizations of the fire. So here you can see a map from INCI-Web, from the government organization. And you can see the extent of the fire. You can see down at the bottom the individual days of where like the most acres the fire took over. You can see it goes up and down due to low pressure systems, due to winds, westerly winds, and other things. But you can't really see that the winds cause this, low pressure systems cause this, or like a high pressure system or a low pressure system brought in rain, which covered 80% of the fire area and really died it down at the end. So that's after this big peak. But you have to imagine the spread in your head. You have to know what an acre is. You have to know how large that is. So this is a better visualization. This is a different fire. This is the Caldor Fire. It was in the El Dorado National Forest, east of Sacramento. And here you can see the extent of the fire. You can see each day how much area in kilometers squared that it spread. This is better. It tells a better story, but it's not immersive like a narrative visualization. You can see, again, how much fire, but you don't see what caused the fire to spread. You don't see the damage of the fire. So, not going to blind you. Okay, so here is my narrative visualization. So here you can see the terrain is Aster DEM data. You can see a mini map in the top left of the map. There's a compass at the top showing the degrees from north. We're going to switch over to the mini map. So you can see the latitude and longitude of the player. And here's a graph at the bottom. This is showing the area of the fire at each day. And at the bottom here, you can see this little nodule. You can grab that and move that. And here you can see the story of the fire, and you can also see some specific data if you really want to see some specific data, like wind direction, wind speed, NO2 density, everything else. And we'll see as I move this slider, you can see the story is changing. You can see specific important moments in the narrative visualization of the fire as it changes. And I'm going to go to the very beginning of the fire, September 10th. So this is where the cabin fire was contained, and the Colony and Paradise fires kept growing to when they would combine at September 17th. So we're going to go into this fire down at the bottom. So this is one of the first fires caused by the lightning. I'm going to zoom in, and we can go in, and you can also see the wind vectors, and those change as you change the time, and that is based off the Mayor 2 data set. So we're into the visualization. So we're at the fire, can walk around, see the fire, see how intense it is. The bigger the fire, the more intense it is that it was captured. It's based off the temperature that it was captured at. And you can see the wind speed changes, the wind direction is changing in the trees. And the trees are actually blowing in that direction at that point in time and space. And you can see the NO2 density is normal right now. But that's going to change in future. So yes, and the fire is based off the MODIS data set. So we have multiple data sets all combined into one simulation that you can walk around in. And I will go to the next one. So this is another scenario. Somebody's using it. They're going to open the graph, open the story, and they'll see, where do I want to go in this fire? So they'll read the story, read what's happening. So we're going to go to October. So beginning of October, the most intense part of the fire. So we'll see that the low pressure system moves in, bringing winds, which caused a lot of the fire to move and spread very rapidly. So it was acres and acres. So you can see many, many fires happening, many hot spots. So you can go into these hot spots, walk around, and see the fire. I'm going to open the data again just to see how the data is going to change. So you can see the NO2 density is going to change. We're going to zoom forward because it's got to go quicker. But you can see where the player is. And when you exit this mini-map, when you exit this screen, you are teleported to that location. So you can see the fire and the smoke. And it's replaying again. So what is this used for? What is this useful for? So it's very useful in educational environments. The goal for this is to put it onto a tabletop display that you can interact with, to teach people about the fire, how it spread. It's very accessible because for a normal 2D visualization, a graph, you need a bit of scientific knowledge, you need a bit of expertise. People might not know what an acre is. People might not know how fast meters per second is. So if you are in the visualization, if you are walking around, you're immersed in it, you can see how fast the trees are blowing in the wind. You can see how big the fires are. You can stand next to them. You can see where the smoke is going. And eventually, this is a very new field, adding these layers to tell a data story. So even virtual reality, even more immersive. You can be immersed in the world rather than just on a tabletop display. Or even augmented reality. You can have the fires standing next to you. You can see the trees in your own environment, so you can see the scale even better. And really, even beyond educational purposes, it's very good for just having a way to reenact the fire, because you can't go back in time. You can reenact the fire with all this data that we've captured using NASA satellites, and you can, for professionals, it's really great to walk around and see the extent of the damage that happened at that time, to see how the winds were blowing, how much wind was being caused by the fire, because the winds were getting so, the fire was causing such great winds that it was stripping trees of bark. So you can really see the wind speeds at this time. And yeah, so sum it up, the narrative visualization here is very good for just showing normal people an easy and interactive and non-professional way to enjoy NASA Earth data, and that's pretty much all I got. I'd like to acknowledge the NASA Impact team, Dr. Manil, Maski, Slesa, and Jerica. I'd also like to thank my advisor at the University of Alabama Huntsville, Dr. Haeyong Chung. I have contacts, and thank you. Thank you for watching. I'll take any questions if anybody has any.